This is 3-4 perpendicular lines. Take a look at the warm-up. Remember when solving inequalities, you solve them just like you would solving equations, but if you multiply or divide by a negative, you're going to have to flip the inequality sign. The warm-up number 1 is x is less than 13. In warm-up number 2, you have to subtract x from both sides to get the variables together. On one side, we end up with 2x plus 1 is greater than 0. Subtract 1 from both sides, and 2x is greater than negative 1. Divide both sides by 2, and you get x is greater than negative 1/2. Example 3, divide both sides by 5, and you get y is equal to 18. In example 4, you can subtract 15 from both sides first. We get 5x equals 75. Divide both sides by 5, and x equals 15. For the system of equations, since y is almost isolated, I would divide both sides by 6 to isolate y. And so we end up with y equals 15, and now we can just substitute that in. So 8 times 15 minus 3x equals 90. Now we can solve for x. When I went through all my steps, I ended up with x equals 10. So x is 10, y equals 15. We can write that as an ordered pair, 10, 15. Okay, what's important from this paragraph is the shortest segment from a point to a line is perpendicular to the line. So the line that's perpendicular is the shortest segment, like in this case, AP. The distance from a point to a line is defined as the length of the perpendicular segment from the point to the line. So example 1a, name the shortest segment from point A to line BC. Well, from point A to line BC, the shortest would be that perpendicular line, which is a line segment, AP. Write and solve an inequality. Well, since we know that that's the smallest side, that means that 12 is going to be less than x minus 8, the length of the other side, AC. And so then I can solve this, add 8 to both sides, and I get 20 is less than x. Usually we write the variable first, so I would have to flip this whole inequality around so that less than becomes greater than now. X is greater than 20. Okay, now take a minute and try where it says now you try. Pause the video and hit play when you're ready to hear the answer. So name the shortest segment from point A to line BC. Well, from A to line BC, that's that perpendicular segment right there. So that shortest line would be AB. Line segment AB. And then write and solve an inequality. Well, since x minus 5 is the shortest side, it's going to be less than any other side. So they gave us the length of 12 for AC. It's going to be less than 12. Add 5 to both sides, and x is less than 17. Okay, these are our perpendicular theorems. I'm looking down at my if-then statement that's been shortened for me. If two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. This arrow tells me this is an if-then statement. So it's saying if we have these two intersecting lines that form a linear pair of congruent angles, then we know those lines. So then the lines are perpendicular. So what I'm saying is if I have a straight line intersecting another straight line, and we have a linear pair of angles here, I know that if these angles are congruent, they must be 90 degrees each because it needs to total 180. Okay, the perpendicular transversal theorem, this one has a name to it. In a plane, if a transversal is perpendicular to one of the two lines, if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other line. So what I'm saying is, if you have one line perpendicular to one of the parallel lines, think about this. If I do corresponding angles, this angle right here would corresponds with this angle. Since they're parallel, those corresponding angles must be congruent. That's really what we're saying. If one of these is parallel, if one of the parallel lines, is perpendicular, if one of the parallel lines is perpendicular to the transversal, then the other one must be as well. And this is sort of the reverse of that. If you have two that are perpendicular already, then these two lines must be parallel. So the shortened version, here's my arrow, so I know it's an if-then statement. If two lines are perpendicular to the same line, then those two lines must be parallel. Okay, let's look at a couple of proofs. Remember, you won't be assessed on proofs, but I just want you to feel comfortable seeing them and thinking through them. So we're given that R is parallel to S and angle 1 is congruent to angle 2. So that's already been listed in my two-column proof. Okay, if we're told that we have parallel lines and that angle 1 and angle 2 are congruent, let's think about what else we might need to know here. In the end, we're trying to prove that R is perpendicular to T. I'm going to mark up that we have parallel lines because that was given, and then I'm going to mark that angle 1 was congruent to angle 2. I'm going to look and see what else we might know. I do know that angle 2, since these lines are parallel, I also know that angle 2 is going to be congruent to angle 3, and that's because of corresponding angles postulate. Now, I'm not writing converse because I'm not proving those lines are parallel. I already know they're parallel. So I'm saying that since they're congruent, they are congruent because of the corresponding angle postulate. Now, if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then I know that angle 1 is congruent to angle 3 by transitive property of congruence. And if angle 1 is congruent to angle 3, then these must be right angles because this is a linear pair. So remember, there was a theorem that said if two intersecting lines form a linear pair, of congruent angles, then the lines are perpendicular. Okay, in this problem, we're given that angle EHF, it's already marked for us, EHF is congruent to angle HFG. Well, why would they tell us that we have congruent angles here? Those are alternate interior angles to me if those lines are parallel. So I'm going to say that EH, since we know that they're congruent, EH must be parallel to line FG by the converse of alternate interior angles. And we're missing a given here, so I'm going to throw that in. FG, let's mark my parallel lines too. Now FG, line FG is perpendicular to line GH. That was given. Let's look at that. Line FG, it's marked here for me, is perpendicular to line GH. Well, why would they tell me that? If one line is, if one pair of intersecting lines is perpendicular, then another pair would be as well. So now I can prove that line EH is perpendicular to line GH by the perpendicular transversal theorem.